Welcome to IoT Practical video series. Myself Professor Ganesh Attarde from ENTC Department SITRC Nashik. Today we are going to see the first practical of the subject Internet of Things of BENTC 2015 pattern SPPU, which is the elective one. The first practical title is Study and Survey of Various Development Board for the IoT. So let's move toward the theory of this particular practical. The aim is study and survey of various development boards for IoT. So IoT is nothing but the Internet of Things. So the learning objective of this first practical is the understand the basic concept of IoT, then the study of Arduino Uno, study of Raspberry Pi, and the study of ESP8266. So what is IoT? First we will search on the internet for the definition of the IoT. So if I'm going to the Wikipedia, the definition of the IoT is the network of physical devices, vehicles, home appliances and the other items embedded with the electronic software, sensor, actuator and connectivity which enable these things to connect and the exchange data, creating opportunities for more direct integration of the physical world into the computer based system, resulting in efficiency improvement, economic benefit and the reduced human intervention. So this is one of the famous definition of the Internet of Things. So this definition we are taking from the Wikipedia. Let's move toward the introduction of the IoT. So IoT refers to the platform where the smart space network with interoperability protocol form the physical and the virtual identities for the addressing them. So the IoT, if I'm talking about the very basic of IoT, the IoT is nothing but the any device, any embedded device which is connected to the internet is known as the IoT device, and that device is known as a node of that IoT. So if we are talking about the IoT functional blocks, these are the block diagram of the IoT. So first one, what the IoT contains? The IoT contains the sensors. The sensors might be wired, the sensor might be wireless. And what the sensors are, what we are getting from the sensor, we are getting the data in terms of the analog or in terms of the digital. So we are processing that data in a processing unit, and we are going to store that data in a storage. So that storage might be the local storage or might be the global storage. Generally the global storage is known as a cloud server. Now from the cloud, if your data is stored on cloud server, the users can get that data through the application, and you can use that particular data for making the decision. So what is now device? The device is nothing but an IoT system relies on device that provide the sensing, actuation, control and monitoring activities. IoT devices can exchange the data with other paired device and the application, or fetch data from other node and process the data either locally or send data to centralized servers like Raspberry Pi or the cloud-based application. Let's see one example. There is one temperature sensor is connected at your home, and suppose if you want to get what is the temperature actually present in your at your home currently. So for that purpose your temperature sensor should be connected to the internet, and you should also connect it to the internet through the application, okay, or through the device. So using that device you can get the data which is very far away from your device, or through the internet. So that's why it is known as a Internet of Things. So things is connected to internet, that's why the name is given as a IoT, Internet of Things. So IoT communication protocol generally works in a data link layer, network layer, transport layer and the application layer. The inter-device must have a wide range of hardware protocol quite support including SPI, I2C, Modbus, etc. So next one is management. The management block provides the different functions to regulate an IoT system to seek the underlying to seek the underlying uh, to seek the underlying administration of IoT system. This follow an IoT system must process a mean of providing some feedback for every action taken against cause. And security. This functional block secures the entire IoT system by providing the activities such as authentication, authorization, privacy, message integrity, secure data storage, and the data security. The application layer plays a crucial role in terms of the user intervention, user interaction that provide the necessary triggers to control and monitor various aspects of IoT system. So we will move toward the second topic, that is the IoT Development Board. So very first development board and very widely used board is the Arduino. So Arduino board is a freely available open source development microcontroller which is capable of doing a very easy programming, and you can also program the IoT device by using Arduino. Arduino is actually the combination of the hardware and the software. So this is the diagram of the Arduino. This is known as Arduino Uno. The Arduino Uno is having the microprocessor at Mega 328P-PU, and it is having the 14 IOs, that is 0 to 13. The out of which the 0 and 1, these are used for the serial communication, and pin number 3, 5, 6, 9, 10 and 11, these are the PWM signal. The remaining can be used as a simple digital IOs. There are total 6 analog inputs are given, that is A0 to A5. So you can connect the 6 analog sensors to this Arduino, and here the 5-volt ground and the V in this power supply is also available here. So next board is the Raspberry Pi. The Raspberry Pi board is a small size Broadcom BCM2835 SoC board, ARM11 power my mini computer. So it is nothing but the computer. The Raspberry Pi actually is having all the essential thing that your computer require. That is, it is having the RAM, it is having the ROM, it is having the CPU, and it is having all the input output device, just like mouse and keyboard and the VGA controller or the HDMI controller. So this is the diagram of the Raspberry Pi. Actually here you can see here, this is nothing but the USB. Actually there are the 4 USBs are given for Raspberry Pi 3.0. Here the Ethernet port is given, here the HDMI port is given, and here the power cable. You can power up this Raspberry Pi using this power up. Here the audio output is given, and here you can connect the camera. Here the camera module is there, and here the GPIO is taken out here. Next board is the ESP8266. It is the very commonly used for the IoT application. This first board is known as a Node 1. This Node 1 price is only 150 rupees. The second board you can see here, the Node MCU. This Node MCU 1.0, the price of this is only the 350 rupees. You can program these two boards by using the Arduino software. Now you can connect your home internet using this ESP8266 by using the Wi-Fi. So it is having the on-chip Wi-Fi controller. So here the comparison of these three boards. First one is Arduino Uno, second is Raspberry Pi, and third is ESP8266. So we are comparing in terms of the different parameters, just like processor, GPU and different. So first processor, Arduino Uno is having Atmega 328P processor. Raspberry Pi is having quad-core ARM Cortex A53. GPU, your Raspberry Pi is only having the GPU. The operating voltage, Arduino Uno works on 5 volt, Raspberry Pi also works on 5 volt, and ESP8266 works on 3.3 volt. Clock speed, it is a clock speed of Arduino is 16 megahertz, Raspberry Pi is 1.2 gigahertz, and the ESP8266 is 26 megahertz. So from this you can see here the fastest your board is the 1.2 gigahertz, that is Raspberry Pi. System memory is only 2 KB, 1 GB and less than 45 KB. Flash memory 32 kilobytes, and ESP8266 your Node MCU is having up to the 128 MBs of memory. EEPROM, your Arduino Uno is having the EEPROM, Raspberry Pi and ESP82 is not having the EEPROM. Communication supported, Arduino Uno can support the Wi-Fi for that is IEEE 802.11b G or N, 802.15.4 433 RF, BLE 4.0 via the shield. So directly this protocol is not supported, but you can connect the shield, Arduino shield, to your Arduino Uno to get connected to the Wi-Fi. Raspberry Pi is having the on-chip on-chip Wi-Fi and on-chip Bluetooth connection. ESP8266 is only having the Wi-Fi, on-chip Wi-Fi. Development environment, you can program the Arduino Uno by using Arduino IDE. Raspberry Pi you can program by using any Linux compatible platform, and ESP8266 you can program by using IDE Arduino or the Lua loader. Programming language is the first one is the wiring, second one Raspberry Pi using Python, C, C++, Java, Scratch and Ruby, and ESP8266 you can program by using Raspberry wiring C or C++. IO connectivities, your Arduino Uno support SPI, I2C, UART and GPIO. Your Raspberry Pi support SPI, DSI and the UART, and ESP8266 only support the UART and the GPIOs. So conclusion is there are several initiatives to realize the IoT application using Arduino. The comparative study shows how these platforms are promoting the growth of the IoT by utilizing a specific board as per the intended application. The detailed analysis here shows in the above table. So out of this you can suggest that ESP8266 is the low cost device. It should be the first choice to implement the sensor network in an IoT scenario, because your IoT device should be the cost effective, and out of these three the ESP8266 is the very cost effective. So in this way we have completed our first practical of the IoT. Thank you for patient listening. Thank you very much.